Hello and welcome to another lab series video from BlockChyp. Today we're going to talk about a new device that we're rolling support out for in the next week or so, along with a couple of new software features that we've added to sort of fully take advantage of this device. This is called the Equinox Luxe 62200M. It comes in a number of different configurations. It's mainly meant for kind of walking around untethered types of payment scenarios. It comes with an optional printer with a Wi-Fi built in, and optional LTE radio so that you can actually process payments over cell networks. So I'll talk about we're targeting this device for a couple of scenarios. The most obvious one is probably pay at the table, and I'll talk about that. But also doorstep payments, the ability to present a payment terminal, on a customer's doorstep when you're doing a delivery, and being able to capture a lower interchange contact or contactless EMV payment as opposed to a telephone order or e-commerce. So I'll start by showing the basics. The terminal works just like any other existing BlockChyp terminal. You can do anything with this terminal that you can already do with a BlockChyp terminal. It's not a different coding interface. Everything works the same way it always has. You can see I've already activated the terminal. And other than the fact that it looks a little different, everything else is basically the same in here, right? So what I'll do is I'll start with just a basic ping transaction. I'm using, for the demonstration today, the BlockChyp command line interface. And this is one of several different ways that a point of sale system or a SaaS application can talk to BlockChyp. We have SDKs for 9 different programming languages. So odds are you won't be using this for yours. This is mainly meant for things that aren't covered by that or for just experimenting with it. But everything that I'm showing you here in the CLI, you can also do in any of the SDKs. And the interface is very similar. So what I'll do is I'll do a ping, and this is just going to help me verify that I can talk to the terminal. I've called it test terminal because I'm creative. There you go, I've run the transaction. Everything comes back as JSON, and you can see success is true. So what I know now is I can talk to the terminal, it's online, and my API credentials are good. The next thing I'll do is just a basic synchronous transaction, meaning a normal BlockChyp charge transaction. Again, this is going to be a test transaction, so I have to add the test flag. The terminal is going to be test terminal. The type is charge. And let's make the amount something like 34. Okay. So I'll do that. Terminal wakes up, and I'll go ahead and tap a card. And it's approved, and I get the full JSON response, all the information I need to record the approved transaction. And this is fine. So for any existing payment scenario, this will work just fine. But it's maybe not the best fit for pay at the table or doorstep payments. It makes the integration problem much more complicated if the only way that the point of sale and the terminal can interact is with a synchronous blocking API call. So what we've done to support pay at the table specifically is we've added a new flag called async. And so what you can do is you can basically send a transaction to the terminal and then but not wait for it to respond. Just check on the status of the transaction later. So the first thing you would do to make that happen is you add this async flag. But then in order to refer to the transaction later so you know what we're going to call it, you need to add something called a TXRef. Now if you're already using BlockChyp, you probably are already doing this because you have to do this for timeout reversals. But it's best practice to add this TXRef for every transaction. Now what this value is, it's really up to you. It could be more or less anything. But what it typically would be is the point of sale system's what you're probably already calling a tender ID or a payment ID. It's generally not a good idea to send order ID or invoice ID because there could be split payments, right? We want to tell them apart. So yeah, so I'll send this, I'll run that, and I just sent the transaction over. You can see it wakes up. I'll do a contact one this time so you can see how that works. The slot is at the bottom, so I'll put that in. And you can see it's approved. So that's good, the customer has paid, but the point of sale system doesn't know that yet. So the next step is, how we intend for this to work is maybe if the cashier or the server walks by the table and notices that they're seeing approved or it's gone back to its default state, they can pick the terminal up, go back to the point of sale station, and then recall the order, and then maybe as part of loading the order, you would go back and check the status to know if it was paid. And now I'll show you how to do that. there is another BlockChyp API call called TX status. And all you do is pass in whatever value you passed in before for TXRef. So I'll just copy and paste that. And now you can see I get all the information. I see that it was approved. I have auth codes. I have all the usual stuff that you would get from a BlockChyp transaction. Another interesting thing that you can do with this is if you are moving more towards a pay-at-the-table model, then the conventional credit card workflow for fine dining might be able to change a little bit, because typically what happens in fine dining or table service is the server brings you a check, you give them a card, they go pre-authorize the card for the whatever the check amount is, then you'll write in a tip, then they'll go in and do a tip adjustment or a capture later on. Well, if it's pay at the table, you don't necessarily need to have two different steps. You can capture the tip when the card is initially charged. So what we can do to support that is, let's change our TXRef here just to keep things up. Let's go back to the charge transaction. There we go. So I'll go back to the previous transaction that we ran. I'm going to slightly change the TXRef. Then I'm going to add a new flag called prompt for tip. And now you can see what happens is that now I see a tip prompt dialog on the terminal itself. I can enter a custom amount. I can pick a pre-configured percentage, and those are configurable on a per merchant basis. And now I can tap my card or my phone or whatever it is. And you can see now that's been approved. The next thing I can, and again, to check the status, I would just go back to my run this TX status transaction. In this case, I've changed the TXRef to that. I'll run that. And you can see I get the normal response back, but you can see I also know what the tip was. So that's how you can lift this value out in the point of sale system to know how to cash your servers out at the end of the night. So that's pretty good, right? One of the next things that you can do with this device is you can do what we call queued transactions, meaning that you can load the device up with a list of transactions that can be recalled later and then processed on recall. This is intended for doorstep payments. And a good use case for this might be pizza delivery. Typically, a pizza delivery driver, when they go out on a run, they're not going to do just one order. They might have 3 or 4 different deliveries they're going to make all at once. What you can do is you can load this device up with all 4 of those orders, and then when the driver gets to the doorstep, they can recall it, hand the device to the person on the doorstep, and then you can actually do a contact or contactless EMV transaction in a delivery scenario, which dramatically will lower your interchange costs because now it's not a telephone or e-commerce payment. So I'll show you how that works, and it's pretty similar. So what I would do is let me go back to one of my other transactions. We'll go ahead and keep the prompt for tip because we typically tip our delivery drivers, especially these days. So what I'll do is I'll change the TXRef, and instead of passing in async, I'm going to pass in queue, right? I'm also going to pass in one more thing, although this is optional, but it helps identify transactions. You can add a description just to help whoever's going to be recalling transactions identify which transaction is which. In a delivery scenario, this is probably going to be the address. So I'll go ahead and put in BlockChyp's old address here in Kennewick. Okay, so now I do that, and you can see now what the terminal displays is a list of transactions, one of which includes the address. So I'll go ahead and put another transaction in here, just so we have more than one. So you can see what that looks like. And I'll put in BlockChyp's old address, which was, could you just move? Ridgeline, okay. And you can see now I've got 2 transactions loaded into the terminal. So now what I can do is, let's say that I'm out on my delivery rounds. I walk up to the doorstep. I basically just touch the one that I'm at. If I'm here by mistake, I can always go back. I can even delete a transaction from my list if for some reason they pay in cash or there's some kind of a problem. But ideally, they're going to do process. I do process. You can see I get the same tip prompt that I showed you before. I'll tip generously. And I'll go ahead and tap a card. And there you go. And then the process of looking up the transaction to see if they've paid or not, exactly the same as it would have been for the async transaction. You just run the transaction status API to determine that. Another interesting aspect of this device is that, because if you think about a doorstep payment scenario, uh, the way that this would have to work is either the vehicle being used for delivery would have to have Wi-Fi in it, probably not the optimum scenario, or you would have an LTE radio built into the device. And so that's how this works. But what if for some reason there's no cell coverage or there's some kind of a problem out there? Well, the BlockChyp store and forward features that already exist also work in this scenario too. So store and forward does work in a doorstep payment scenario. So there you have it. That's the Lux 6200M. So as of right now, we've got a software release coming out. It's probably going to ship over the weekend that will include these new asynchronous and queued transaction features. They're pretty much wrapped up. And then developers who want to start working with this device are free to talk to us or order a developer kit at any time. You can get your hands on one of these and start experimenting with your scenario. Just let us know if you need Wi-Fi or LTE or special features. So that's about it. I want to thank everybody for watching on the Lab series, and we'll see you next time.